Good day, ladies and gentlemen. It is my pleasure to be here today to present to you on the topic of reduced graphene oxide from agricultural waste. First of all, let me introduce myself. My name is Jamarosliza binti Jamaluddin from University Teknologi, Malaysia. Before I begin, I would like to provide you with an outline of what I will be covering during the presentation. First of all, I will start my presentation with highlight and introduction. So in these sections, I will introduce you on the graphene oxide, and reduced graphene oxide. So after that, I will explain to you on the source of reduced graphene oxide. And after that, okay, so I will share with you a related study on reduced graphene oxide from agricultural waste. Finally, I will end my presentation with some conclusion. So without further ado, let's get started with the first section of my presentation. In these sections, in this slide, I will share with you the current state of the graphene market. Recent research has shown that the graphene market is set to reach an incredible milestone. The global graphene market will reach the 1 billion mark by 2025. So what I can say here, this is a significant achievement in a graphene industry. Graphene is a two-dimensional material that consists of a single layer of carbon atoms arranged in a hexagonal lattice. Despite its simple structure, graphene possesses a remarkable set of properties that make it unique among other materials. Graphene is incredibly strong and stiff and also have a good conductivity. Graphene is a material that has attracted a lot of attention in recent years, and one of the reasons for this, okay, so graphene is a single thin layer of a graphite. While graphene's properties are incredibly promising, its use in practical applications has been proven to be a challenge due to the difficulties in synthesizing pristine graphene. One of the biggest challenges in synthesizing graphene is achieving a high degree of structural perfection. For your information, graphene is very sensitive to defects and impurities, which can significantly degrade the properties. Besides to produce a graphene from graphite, so graphene oxide also can be produced from graphite. Okay, so graphene oxide here, you can see in a B here, can be produced from graphite by exfoliation method. Okay, and then graphene oxide actually is a derivative of graphene that has functionalized with oxygen containing group. So if you see in a figure B here, we can see that the red color ball here represent oxygen containing groups. Okay, so when graphene oxide have the oxygen containing group here, so it makes graphene oxide easier to disperse in solvent and manipulate for certain application. Graphene oxide is highly hydrophilic, meaning it's readily interact with water and other polar solvents. Okay, this is due to the presence of oxygen containing group such as hydroxyl and carboxyl group on its surface. So this one can form hydrogen bonding with water molecule. Besides that, graphene oxide also has a higher optical transparency. So, higher optical transparency. However, graphene oxide has low conductance due to the introduction of oxygen-containing groups. The sp2 hybridization of pristine graphene is partially converted to the sp3 hybridization of hybridization in graphene oxide. Okay, so this resulted in material behaving more like a wide band gap insulator than a conductor with low electrical conductance compared to the pristine graphene. Okay, so the next slide, I will discuss on the reduced graphene oxide. Okay, so reduced graphene oxide here is a form of a graphene oxide. Okay, so that has been treated to remove some oxygen, a functional group, which restores, in order to restore its electrical conductivity. Reduced graphene oxide is a promising material for a wide range of applications, including electronic, energy storage, and sensor. And then for your information, this reduced graphene oxide can be produced from the agricultural waste. As I mentioned previously, okay, so graphene oxide can be produced from graphite. Okay, so there are a few sources of graphite. First is synthetic graphite. This synthetic graphite is produced from petroleum feedstock. Okay, and second one is a natural graphite. So this natural graphite can be found as flakes or crystalline layers in metamorphic rock. And last one, we have the biomass extracted graphite. Okay, so this biomass extracted graphite can be synthesized from biomass or agricultural waste. Okay, as I mentioned previously, we know that graphene is highly versatile and sought after material due to its high electrical conductivity, high mechanical strength, and large surface area. However, producing graphene can be expensive and environmentally unfriendly, so that agricultural waste such as palm oil, coconut shell, sugar bagasse, and rice husk can be sugar bagasse, which contains carbon, can be converted into graphene oxide. Then after that will be produced reduced graphene oxide. So from here, we can see that there are several studies has successfully produced the reduced graphene oxide from agricultural waste. So, for example, here we have one researcher here. So, Sugiono et al. 2020. So, Sugiono synthesis graphene oxide and reduced graphene oxide from coconut shell waste via modified hammer method. Okay, beside that, we have Lee et al. 2018. So Lee et al. Synthesized a graphene oxide and reduced graphene oxide from sugar cane bagasse by using modified hammer method. So this is another recent study on producing of a graphene oxide and reduced graphene oxide from the agricultural waste and biomass. So you can see here they have a few study, okay, recent study on graphene oxide, on producing graphene oxide and reduced graphene oxide from the agricultural waste. So there are several methods to produce a graphene oxide. Okay, the first method is known as hammer method. Okay, so which is this hammer method is the most common approach to produce graphene oxide. Second one, we have the Tours method. Okay, Tours methods involve the use of household blender to exfoliate graphite flakes into graphene oxide. The third one is a Brody method. Okay, so this Brody method involves the use of a mixture of graphite and fuming nitric acid. This method is less hazardous if we compare to the hammer method, but it requires long reaction times and yield low quality of graphene oxide. And the fourth method, we have the Staudenmeier method. This method is similar to hammer method, but it uses a different oxidizing agent. This method has low risk of explosion, but it's less effective at producing high quality graphene oxide. Last but not least, we have the Hoffman method. And this Hoffman method involves the use of an electrochemical process to exfoliate graphite flakes into graphene oxide. Okay, among this method, the hammer method is a widely used method for producing graphene oxide and considered the best method for producing graphene oxide. This is because from hammer method we can produce graphene oxide with a high degree of oxidation, and also we can produce graphene oxide with a large surface area. So it makes the graphene oxide highly suitable for various applications. Second one, the hammer methods allow the precise control of degree of oxidation and the size distribution of the resulting graphene oxide sheet. The last one, okay, the hammer method is highly scalable and can be used to produce large quantity of graphene oxide. So now I will focus only one method in my presentation today. So I will focus on the hammer methods. Okay, there are three types of hammer method. First is the original hammer method. Second one, we have the modified hammer method. And lastly, we have the improved hammer method. So next, we will see what is the difference between the original hammer methods, modified hammer method, as well as improved hammer method here. So for the hammer method, for hammer method, it uses a mixture of concentrated sulfuric acid, sodium nitrate, and graphite flakes, which are gradually added to the mixture with constant stirring. So from hammer method, okay, we will produce the mixture. Then the resulting mixture is then further oxidized using potassium permanganate. So for the original hammer method, we will use potassium permanganate as the oxidizing agent. And for the modified hammer method, so in modified hammer method, we will add the reducing agent such as hydrazine and hydrogen peroxide to the mixture in order to reduce the degree of oxidation. So from the modified hammer method, we can improve the quality of the resulting graphene oxide, and also we can reduce the amount of hazardous waste generated during the process. Okay, so what we can see here, when we use a modified hammer method, we can avoid of using the hazardous materials such as the potassium permanganate. So last one in hammer methods, we have the improved hammer method. So for the improved hammer method, it uses of a more concentrated mixture of sulfuric acid and sodium nitrate, which allows of the greater control over the degree of oxidation and the size distribution of the resulting graphene oxide sheets. And also from the improved hammer method, it can be produced graphene oxide with a high degree of oxidation and a larger surface area than the original hammer method. So from these three methods, improved hammer method is the best method for the hammer method. Reduced graphene oxide is a highly versatile material with a wide range of potential application in different fields, including, so this is the application of reduced graphene oxide. So the graphene oxide can be used as supercapacitor, and also we can use the reduced graphene oxide in a solar cell, biosensor, as well as high sensitivity of multi-sensing materials. So other than that, we have another application of reduced graphene oxide. So this is my last slide for today. So before I end my presentation, I will give you some conclusion from my presentation. So from here, I can conclude that, okay, the development of sustainable and eco-friendly, high-quality reduced graphene oxide has captured the interest of researchers around the world. As we have discussed, one of the promising approach is the use of agricultural waste to produce graphene oxide, which has many advantages. By utilizing agricultural waste, countries with high agricultural crop production can manage and repurpose this waste, turning it into valuable resources. This not only benefit to the environment, but reducing waste, turning it into valuable resources. Okay, so means that this not only benefit to the environment by reducing waste, but also creates the new opportunities for industries and technologies. Therefore, exploring the potential of agricultural waste as a source of graphene oxide is a crucial step towards a more sustainable future. So, thank you very much for your attention.